Welcome to NM's Arena. In this video, let us try to solve some problems involving multiplication of matrices. Our first question is prove that P into Q plus R is equal to PQ plus PR. We have to prove that the left hand side is equal to the right hand side. Left hand side is this P into Q plus R. That is equal to the right hand side, that is PQ plus PR. So first of all we have to get the matrix. P matrix is given matrix of 0, 1, 2, 3 and Q is equal to matrix of -1, 2, 4, 3 and R is equal to matrix of 2, -1, 6, 5. Using these three matrices, we have to prove that P into Q plus R is equal to PQ plus PR. First, let us take the left hand side, P into Q plus R. For that, we have to get Q plus R. Q plus R means Q matrix plus R matrix. So, each element has to be added with the corresponding element in the other matrix. For that purpose, the rows and columns of both the matrices must be the same. Q matrix is a 2 by 2 matrix. In the same manner, R matrix is also a 2 by 2 matrix. So, this addition is possible. Now, let us try to add Q and R. -1 plus 2 is 1. 2 plus -1 is 1. And 4 plus 6 is 10. 3 plus 5 is 8. So that is Q plus R. Now we have to multiply P with Q plus R. P into Q plus R. So P comes first. P matrix into Q plus R matrix. So this is the P matrix and this is the Q plus R matrix. We have to multiply this matrix with this matrix. First of all, we have to see whether we can do this multiplication. The P matrix is a 2 by 2 matrix and Q plus R matrix is also a 2 by 2 matrix. So the number of columns of the first matrix is equal to the number of rows of the second matrix. Thus, this multiplication is possible. Then we have to execute the multiplication. 0 into 1 plus 1 into 10. That is first row of the first matrix and first column of the first matrix. 0 into 1, that is here, plus 1 into 10. So this first row and first column is over by getting this element. And then for getting this element, we have to consider first row of the first matrix and the second column of the second matrix. That is 0 into 1 plus 1 into 8. Thus, we get this element. Now coming to the second row, we have to consider the second row of the first matrix and first column of the second matrix. 2 into 1 plus 3 into 10. Thus, we get this element. Now for getting this element, we have to consider the second row of the first matrix and second column of the second matrix. That is 2 into 1 plus 3 into 8. And we get all the elements. Now we have to do these multiplications and additions. That is 0 into 1 plus 1 into 10 is 10. 0 into 1 plus 1 into 8 is 8. 2 into 1 plus 3 into 10 is 32. 2 into 1 plus 3 into 8 is 26. So, this is the P into Q plus R matrix. That is the resultant matrix after multiplying P with Q plus R. And our next step is finding the PQ. That is P into Q. This is P matrix and this is Q matrix. P into Q. Let us see whether this multiplication is possible. P matrix is a 2 by 2 matrix and Q matrix is also a 2 by 2 matrix. Since the number of columns of the first matrix is equal to the number of rows of the second matrix, the multiplication is possible. And we can do the multiplication as we have already discussed in the previous step. Thus, we get the resultant matrix as matrix of 4, 3, 10, 13. This is the P into Q matrix. And our next step is multiplying P matrix with R matrix to get this part. P into R. P matrix into R matrix. Now the P matrix is a 2 by 2 matrix and R matrix is also a 2 by 2 matrix. The number of columns of the first matrix is equal to the number of rows of the second matrix. Hence, we can proceed with the multiplication of these two matrices. Thus, we can do the multiplication. That is, for getting all these elements, we can follow the steps that we have already discussed. That is, the first row of the first matrix and the first column of the second matrix to get this element. First row of the first matrix and second column of the second matrix to get this element. Then coming to the second row of the first matrix and first column of the second matrix to get this element, second row of the first matrix and second column of the second matrix to get this element. And then these additions and multiplications can be performed to get the PR matrix. This is the PR matrix, matrix of 6, 5, 22, 13. And next, we have to find whether the left hand side is equal to the right hand side. The left hand side given in the question is P into Q plus R. And we have found that P into Q plus R is matrix of 10, 8, 32, 26. And we got PQ as matrix of 4, 3, 10, 13 and PR as matrix of 6, 5, 22, 13. Now, we got the left hand side as such, and for getting the right hand side, we have to add PQ matrix with the PR matrix. And PQ plus PR is equal to PQ matrix plus PR matrix. And that addition gives rise to another matrix, that is matrix of 10, 8, 32, 26. Thus, the left hand side, that is P into Q plus R, that is equal to the PQ plus PR, or the left hand side, as both of these matrices are same. So, it is proved that the left hand side P into Q plus R is equal to the right hand side PQ plus PR given in the problem. Hence, it is proved. And next, let us consider another problem. Here, we are asked to show that a square minus 4a minus 5i is equal to 0 and a is given as matrix of 1, 2, 2, 2, 1, 2, 2, 2, 1. So each of these elements we have to find out. We have to find a square, we have to find 4a, we have to find 5i. And by subtracting this 4a from this a square, and from that again we have to subtract 5i, and we should check whether we are getting 0 as the answer. For that, let us begin with a square. A square means a into a, that is a matrix into a matrix, and we have to check whether this multiplication is possible. A matrix is a 3 by 3 matrix and second time again a 3 by 3 matrix. So, the number of columns of the first matrix, that is this one, is equal to the number of rows of the second matrix. Thus, the multiplication is possible. And we can do the multiplication which will give rise to a resultant matrix as shown here. Matrix of 9, 8, 8, 8, 9, 8, 8, 8, 9. Now we got A square. Then we have to find 4A. This is a scalar multiplication. 4 into A matrix, that is matrix of 4, 8, 8, 8, 4, 8, 8, 8, 4. Now we got 4A. Next is 5I. 5I means 5 into identity matrix. Identity matrix is often indicated as I, or the capital letter I is used to indicate identity matrix. So 5 into identity matrix or the unit matrix, that is equal to matrix of 5 0 0 0 5 0 0 0 5. Now we got all this: A square, 4A and 5I. And let us proceed to our next step. We have to find A square minus 4A minus 5I. This is A square minus 4A minus 5I. So first we have to subtract from this matrix, we have to subtract this matrix, and from that we have to subtract this matrix. Or we can do this subtraction together. That is, each element of each matrix corresponding position can be selected and subtracted. That is 9 minus 4 minus 5. In that way also we can do the subtraction. That is together. 9 minus 4 minus 5. That is the first element. Then 8 minus 0. That is this element. Then 8 minus 0. That is this element. Then coming to the second row, 8 minus 0, that is this element. So we have to consider the same element in the same position in all the three matrices, and thus we get the answer as matrix of 0 0 0 0 0 0 0 0 0, that is equal to 0. Thus it is proved that A square minus 4A minus 5I is equal to 0 when the A matrix is the given matrix in the question. That is how we solve this problem. And our next question is a word problem. Two shops have the stock of large, medium and small sizes of a toothpaste. The number of each size stocked is given by matrix A. This matrix gives the stock of large, medium and small sizes of toothpaste. That is, the first row is shop 1. In shop 1, 150 large sized toothpaste are there and 240 medium sized toothpastes are there and 120 small sized toothpastes are there. In the same manner, the second row shows the stock of toothpaste in shop number 2. That is, large toothpaste is 90 and the medium 300, small 210. That is shown by the matrix A. And let us read the second part of the question. The cost matrix B of different size of the toothpaste is given. This is the cost matrix. Matrix of 14, 10, 6. And find the investment in toothpaste by each shop. So, based on the stock of this toothpaste and the cost of each toothpaste, we have to find the investment in toothpaste by each shop. Three elements are there in this matrix. That means the first element is the cost of large sized toothpaste. Second element is the cost of medium sized toothpaste. And third element is the cost of small sized toothpaste. And so it is very much clear from the question that we have to multiply the A matrix with the B matrix. A matrix into B matrix. The first column of the A matrix shows the stock of large sized toothpaste. This column shows the stock of medium sized toothpaste, and this column shows the stock of small sized toothpaste. And this matrix shows the cost of each type of toothpaste. First one is large sized toothpaste, second is the cost of medium sized toothpaste, and third one is the cost of small sized toothpaste. So we have to multiply the large sized toothpaste with its cost and the medium sized toothpaste with its cost and the small sized toothpaste with its cost, that is 6. And that is how we do the matrix multiplication. And our next step is to check whether this multiplication is possible. For that we have to consider the order of both the matrices. A matrix is of order 2 by 3 and B matrix is of order 3 by 1. And the number of columns of A matrix is equal to the number of rows of B matrix. Hence, the multiplication is possible. So, we get this as the figures when we multiply it. 2100 plus 2400 plus 720, that is the first element in the first row, and then 1260 plus 3000 plus 1260, that is the second row. Now we get a matrix with only single element in the first row and single element in the second row. This is the resultant matrix. Matrix of 5220, 5520. So, when we multiply a 2 by 3 matrix with a 3 by 1 matrix, we get a matrix in this form. That is with 2 rows and 1 column. We get a 2 by 1 matrix. And this matrix is our solution. The first row shows the investment in toothpaste by shop 1 and the second row shows the investment in toothpaste by shop 2. That is how we solve this problem. So, this is how we solve the matrix multiplication problems. Thank you for watching this video. For more videos, subscribe the channel.